Hi, I'm Kelly with Signature Solar, and today I'm going to walk you through the installation and commissioning of the Solis 11.4 kilowatt high voltage hybrid inverter with the LG 16H Prime high voltage batteries. So as we look at this energy storage system that we're installing today, we're going to focus first on the Solis 11.4 kilowatt high voltage hybrid inverter. It does output 11.4 kilowatts as well as just under 50 amps, 47.5 amps on or off grid. This is a versatile inverter capable of whole home or partial home backup that is scalable up to 6 inverters in parallel, capable of up to 68.4 kilowatts of continuous output. This inverter can even surge up to 18,000 watts for 10 seconds. The other part of our energy storage system are LG 16H Prime batteries. They can output 7,000 watts continuous power. We can parallel up to 2 of these high voltage batteries, and together they can output 14,000 watts of continuous power. So as you can see, we've already assembled our batteries, we have mounted our inverter, and we've installed our conduit. Now it's time to start wiring up our inverter. So the first thing we'll wire up in our inverter are our communications. The first thing you see is the meter A and meter B inputs. That will be our communications with our electricity meter. For this one in our box, we have the Acral meter. Some versions you may get may come with the Chint meter, which has a readout on that meter. They are all functionally the same and install the same way. They have 3 different inputs. On the top left of your meter, this will be your communications with the inverter. On the top right, this will measure the current from your CTs that you will install. And on the bottom left, it will read voltage. So we are using a standard Cat5 cable or RS485 cable, and it doesn't matter which of these cables that you choose to use, as long as whichever color cable that you use in A on the communications board inside the inverter, you use the same color in your Acral meter. If we use orange in A, we'll use orange in the Acral meter, and if we use blue in the communications board in the inverter, we'll use blue in the Acral meter. Now, if we are running this low voltage cable through a conduit or trough with our other high voltage wires, we'll need to use shielded wire with the same voltage rating as our other conductors. So we'll be inserting orange in A and blue in B. And to install these, we'll just insert an electrical screwdriver, push up on this orange tab, insert that into the hole, release, and then give a gentle tug to make sure that it grabs onto it. Let's do the blue side into B. On the other side, to connect our orange and blue communications to our meter, notice we have to connect orange to A and blue to B. We'll use this 4-pin connector. And as we insert it, notice it's the 2 middle ones. But this time, orange is going to go on your right, and blue is going to go on your left. So they'll go in the middle just like this. As we look at the connector, if we don't have to strip the wires as we insert them. They've got some blades in there that will strip the wire for you and make their connection themselves. You want to make sure that your orange clips are lifted up all the way, and to do that, you can use a small screwdriver and go into this bottom slit, insert it in, and just lift up. Make sure that those orange pins are lifted up as far as they can go. And that will open them wide, and then you can just snap them down into place and tug to make sure you get a good connection. Then you can slide this into your RS485 connection, and you've made communication with your Acral meter. Next, we'll set up our communications with our LG batteries and our board for our inverter. We will not use the CAN communications. With LG batteries, it's RS485 communications. So we'll start on our board here with RS485A, RS485B, enable and enable ground. Whichever colors that we decide to use on our RS485 cable, we'll just need to make sure and match those up with the connections in our LG batteries. So for communications with our batteries, we're going to use brown for RS485A+, brown white for RS485B-, orange for enable, and orange white for enable ground. We'll go ahead and connect those now in the same way that we connected our communications for our meter. So if you have stranded wires, or since these are smaller wires, it may be easier to ferrule these ends to get them in here a little bit easier. And the Solis inverter does come with some ferrules for these smaller wires. You may want to put these on the end. I'll show you how to install those now. You can slide these over the end of your stripped wire and use a crimper. And this will make inserting them into your terminal a bit easier. If you have some extra wire hanging out of the end, you can just snip that off, like so. We'll go ahead and do that to the rest of these wires. With our ends ferruled, we're ready to insert these. Brown, brown, white, orange, orange, white. Once again, looking at the communications board, we have brown at BMS 485A, we have brown white at BMS 485B, we have orange at enable and orange white at enable ground. Now that we've got the communication connected inside of our inverter, we're going to move over to our batteries and connect the communication cables inside of our batteries. Since we're connecting two batteries in parallel, we'll have to set up these batteries in communication with each other and then to our inverter. So the battery that is furthest from our inverter is typically our primary battery. The battery that is closest to our inverter will be our secondary battery. We will daisy chain these two batteries together. So we will set up communications to our primary battery. We'll connect it to our secondary battery, and from our secondary battery, we'll set up communications from our secondary battery directly to our inverter, which will be the communications cable that we just connected inside of our inverter. So let's get started with our communications in our primary battery. We are using the same colors that we connected inside of our inverter. We've ferruled the ends and we will connect them just as we did inside the inverter. So we will use orange for enable 12 volt, white orange for enable ground, brown for RS485A+, and white brown for RS485B-. You'll insert your ferrule end inside of the round portion of your terminal. If you take a small flat screwdriver, you can insert it into the small rectangular portion and push slightly. It will open up the portion inside of the circular terminal. And when you insert your ferrule end and you release your screwdriver, the teeth will close down on your ferrule. You can give a slight tug and know that you have a secure fit. So we'll go ahead and insert the rest. White orange for enable ground, brown for RS45A+, and white brown for RS45B-. Since this is the primary battery, or the furthest one away from our inverter, we will need to set our comms resistors to be on or both in the down position on the left-hand side. For our comms resistors, they both need to be in the down position or on. Since this is our primary battery, both of these on the right-hand side need to be in the up position for our ID to designate that this is the primary battery. Now we're going to connect the communications for our secondary battery. We have communications coming from our primary battery, and we have communications that have already been connected for our inverter. We'll combine both of these communications cables and connect them to our secondary battery, which will parallel both of these batteries so that they can both communicate with our inverter. So I've combined each of these communication wires with ferrules. This will make it easier to insert into our communications port. And then both of these batteries will be connected to our inverter and communicating. Orange to enable 12 volt, orange white to enable ground, brown to RS45A+, and brown white to RS45B-, the same as we've connected everywhere else. Okay, now we've got our communications cables connected. We need to also set our dip switches to be in the correct positions. On our left, we've got our comms resistors, and in this case, the secondary battery needs to be in the off position, so we'll change the left comms resistors to be in the up position, which is off. And to change the second dip switch location, we'll change this to the secondary battery, which means the left one needs to be up and the second one needs to be down. So in the second set of dip switches, which is our ID, this designates this as the secondary battery. The left side will be up and the right side will be down. So what you see us installing now are our CTs or current transformers, and they will measure current coming in from the grid. And these will be required for self-consumption or export control for your load management. It is important that you are familiar with where you are applying these with your line 1 and line 2. We'll have to keep that consistent across all of our installation. These need to be installed between your meter and your main panel on your line 1 and your line 2. If you'll notice when you open these up, they have an arrow. Your arrow will need to point towards your grid, and they will simply go around the wire and lock closed. And then you will run your wire through your conduit, and this will connect into your acrometer where you see line 1 and line 2 in the correct inputs. As you move across your communications board, you'll notice there's some inputs for dry contact. That allows you to connect a generator up to your inverter to allow it, based on your settings, to automatically give power to your inverter and to your loads at certain times based on your settings. Moving across your communications board, you'll notice that there is a rapid shutdown input. This has a red jumper in it, which is a keep alive signal. If you wanted to wire up an external rapid shutdown initiator, you could do that. And when you hit that button for emergency personnel, this would shut off any power from the inverter. Many models that Solis provides comes with a built-in rapid shutdown button, which would be installed here on the side. This being a base model, it does not come with that, but if yours does have a built-in rapid shutdown button on the side, it would shut down all DC voltage coming in from your array. If you're looking for the inverters that have the built-in rapid shutdown, Solis offers you some different options. They have built-in AP Smart transmitters, and they also offer ones with Tigo. With Tigo, they offer the ones with RSS transmitters for your fire and safety solutions. They also offer the ones with your optimizers, which use the CCA transmitters. Make sure that you match the right transmitters with the correct receivers for Tigo options. The last thing you'll see on your communications board are your paralleling ports. Inside your accessories kit, inside your inverter box, you will find the paralleling cable. You'll simply take your standard Ethernet cable and plug one end into your in port inside your master inverter, and the other end will go into the out port of your slave inverter, and you will continue to go in to out into each inverter that you have in your system up until you get to 6. All right, now we just have one inverter and we've got some dip switch settings over here on the end of our board. We need to make sure that both of those are in the on position with just one inverter. If you have multiple inverters in parallel, you will need to refer to the manual to see what settings those need to be at for each of those inverters in parallel. Next, we're going to talk about our terminal inputs inside the terminal housing. Starting from left to right, we have our PV inputs. We have 4 MPPTs, each operating separately. They can each take in 16 amps. For each array, you would bring in your positive and negative wires. You would lift open these orange tabs and just slip them up into your input. When you flip down these orange tabs, the teeth would bite down. You would give your wires a tug to make sure the wires were secure. Also, you would bring in your ground wire and secure them to your PE bus bar over here to make sure that you are properly grounded. Now we're ready to connect our battery cables. So we've got a positive and a negative and a ground that we will connect. Our positive and negative will go up through the filter into our battery terminals, and our ground will go over to our ground bus bar. Now our battery cables, our power cables are not connected to our batteries yet. We'll do that after we connect them in the inverter. Now, before we connect our wires to our inverter, keep in mind that we have already run all of our wires. We are just connecting our conductors from our wire trough to our inverter. We'll talk about all of that here in just a moment. Our batteries are not connected, but we do change wire sizes from our combiner box, from our batteries to our inverter. Here we have number 6 gauge wire coming from our wire trough to our inverter, and number 6 gauge wire is the max size that these inputs in the inverter can handle. We'll start with our ground wire going to our ground bus bar. This keeps everything safe as we connect things up. Notice that we have color-coded our ground wire, our positive and our negative wires so that we don't get things mixed up as we connect them down the line. Now, as we take our positive and negative wires up to connect them inside of our battery positive and battery negative terminals, These also have the orange tabs. We will just flip up, insert them into the terminals, and we can flip that orange tab down and give it a gentle tug to make sure that it bites down and we're connected. Now that we've got our battery cables connected to our inverter, we'll connect up the battery cables to each of our batteries. Again, we've got these labeled, even though each of these cables have black jackets, we've got them labeled so that we know which one is positive and negative and our ground. So we see over here, our terminals are labeled positive, ground, and negative. We have already stripped these and put ferrules on the end. And with these, we can stick them in the top round terminal and give them a firm push, and they should catch into the teeth of the terminal. If you give them a gentle tug, you'll know that they are in snugly. So we'll take the green in the middle terminal, which is our ground, give it a gentle tug, and our black into the negative. We'll connect our power cables for our secondary battery. Again, red for positive, green for ground, and black for negative. One of the ways that we're combining the power cables for our batteries, because our inverter only has one input for batteries, is that we're using a mechanical lug with multiple inputs to be able to combine our power cables. This is also known as a multi-tap or a Polaris connector. And what we'll do is we've already ferruled some of these ends. They do not have to be ferruled, so you can either use them with ferrules or without. But what you can do is insert battery 1 power cable, battery 2 power cable, and you can tighten these down with your hex nut. And these are both 8-gauge wires coming from your batteries. Because they're being paralleled, your amperage will increase, and so for safety purposes, we will increase that wire gauge from an 8-gauge to a 6-gauge going into our inverter. So this wire that's going from our batteries to our inverter is our increased wire gauge, which will be our 6-gauge. So we'll tighten that down. Make sure these are good and snug. So those are all good and tight. We can put our caps back in. And once these are combined in this way, we can store these inside our combiner box or trough with all our other wiring. These are rated for 600 volts, just like everything else. Keep in mind, this is for video purposes. When you are installing this for AHJ or authority having jurisdiction, you will need to keep your AC and DC lines separated with some kind of divider. Now we'll wire up our backup panel or our critical loads panel. We're using a 6-gauge wire due to the fact that our inverter can handle 47.5 amps, and the 120% rule means that we will run this through a 60 amp breaker in our backup loads panel. We'll run our line 1, line 2, and neutral to our backup loads panel, and we'll show you how to do that. So with the AC side of things, it's important to note that L1 is typically black, L2 is typically red, and neutral is white. So it's a little bit different for battery being positive red and black being negative. So we'll take our L1, black, flip up your orange tab, insert it into the terminal block, flip down the orange tab, and give it a gentle tug. And we'll follow up with L2, and neutral. One thing to note is this 4th terminal labeled PE is a dead lug. It is there to reference ground, but do not use this one for your ground. Always use your grounds for this ground bar down below. We just connected our backup panel. Now it's time to connect our grid input. Keep in mind, these need to be totally separate connections, as one operates as our off-grid and battery backup, whereas the other one operates as grid import and sellback. For this video and for testing purposes, we are only importing grid. We will not be selling back power. We are wanting to show transfer time and show powering some loads. So again, we've got to make sure we stay consistent with our white being neutral, our L1 being black, and our L2 being red. You should be able to insert these into the terminal input and give it a firm push, and the jaws will clamp down. So if you have trouble getting your wire inside of your terminal block, you can insert a small screwdriver inside this upper rectangle to open up those jaws, and then insert your wires, and then you can release your screwdriver and those jaws will clamp down on your wire. So we finished wiring up everything inside of our inverter. There's one other thing I want to point out is you've got this wiring diagram sticker right inside the inverter that shows you the functionality of the inverter and everything that we've done inside of the inverter. There's one other thing we need to wire up. That's our electricity meter. So let's go take a look. At the beginning of the video, we connected our communications cables and we installed the 4-pin connector here. Next, we're going to talk about installing our CT connections, which measures our current. So when you open up your CT connections from the box, they already come installed into the 4-pin connector. In order to get them through your conduit, you will have to disconnect them. So the way that you'll do that is you'll take a small flathead screwdriver and insert it into this small rectangular hole in the bottom of this connector and move your screwdriver in the upward position, and that will move your pin up. We'll do that for all 4 of these connectors so that these wire terminals will be exposed and these wires can be removed. Now, one thing you'll want to be sure of as you reconnect these and insert your 4-pin connector is that your red will be your L2 and your black will be your L1 so that we stay consistent with everything that we've connected so far down the line. So as we insert this into our meter, L2 will be on the left, negative and positive. So negative will be our black, red will be our positive, L1 will be our black wire coming in with the black side being our negative and the red side being our positive. We'll connect these the same way that we did with our communications cable. We'll insert them into the hole, and when we snap these down, the blade will bite down on the insulation, making the connection secure. The last thing to connect to our meter is our power for our meter and is also going to provide voltage reference for us. So we'll connect the L1, the L2, and the neutral, and we'll do that by this 4-pin connector here. Now this is getting power from our backup loads panel, and we're doing this by going to a double pole breaker in our backup panel. We're landing it on actually 2 20-amp breakers. You also need to make sure that you are getting the phases right here, your L1 going to an L1 bus bar and L2 going to an L2 bus bar. This would typically be on your main loads panel coming from your grid. Now before we actually connect this, I'm going to show you how to connect the acrometer to the DIN rail. So your electricity meter is designed to be installed on a DIN rail inside a power distribution panel. Typically, this would be inside your main panel or in an external box outside your main panel. Now, we had trouble finding a DIN rail, so what we did was we found a nadir breaker box that was rated for 600 volts, and we took out the nadir breaker and we installed this electricity meter inside the nadir breaker box. So what you'll do to install this on a DIN rail is snap it over the top, and then it has a clip that is down on the bottom, and that will just push up to lock it in. We'll do a little bit of wire management here. Now we'll go ahead and plug in our voltage reference. You can see we've got our L2 going to one breaker and our L1 going to another breaker so that it's landed on a double pole breaker. So now that we've got everything connected, it's time for our safety checks. We're going to check to make sure that we don't have any cross polarity for our batteries and for our AC connections on our phases. So we're going to start with our batteries now to make sure that we have continuity between our positives and make sure that there's no cross polarity between our positives and our negatives. Remember, there is no cross polarity protection on the inverter for the battery, so we really need to make sure that we are checking that to make sure everything is set up correctly. To do that, we will turn our multimeter on to the ohms or continuity test, which is the indicator right here. And when we check with our putting one positive into our batteries and one positive into our battery input on the inverter, we'll listen for a beep. That means that we have good continuity across both. When we put one into a positive and one into the negative, we are looking to make sure that we don't have a beep. That way we don't have any pathway for electrons to flow. So putting my black probe into the positive terminal and red probe into the positive terminal, we hear a beep, which means we have a good connection there. And we shouldn't hear a connection if we put it into the negative. So that is good. We have no cross polarity happening. So now we'll check for continuity on our phases from our grid to our backup panel. So what we'll first need to do is flip our inverter to the bypass, which is on our knob over here on the right. We'll flip it to where it says bypass. We'll also turn on our main breaker on our backup panel. So we'll start with our L1. So these should be our black wires. We'll put our black probe on our black wire and on our grid. We have continuity there. To make sure that we don't have continuity, we can check it with the red and with the neutral. So we'll also check the continuity from our backup panel here to the backup panel of the inverter. Okay, we have good continuity from L1 and make sure that it is not crossing phases with the other two, so we're good there. Now to make sure that we haven't crossed phases on our meter, we'll have to flip the breakers that our meter is connected to, make sure that they are both on, and we'll go L1 to the L1 connection. We have continuity there and make sure that we don't hear. So they are on the same phase for L1, and then we can also check it where L1 is connected here by touching the screw there and then make sure that it's not getting any continuity across the other two. We can do the same thing with L2, check all of the red. And then make sure that nothing else is giving us sound. With continuity checked and all safety in place, we're going to begin commissioning our system. To begin doing that, we're going to install a Bluetooth antenna. This is not necessary, but it will extend the range of our Bluetooth. We will also install the data logger, which will allow us to remotely monitor the system. So the Bluetooth antenna will be installed on the back left of the unit. There is a cap that you will need to unscrew. And there is a red cap that you will need to remove. And then this antenna will screw on. And then you can bend it whichever way you need to for best range. The data logger will be installed right here on the front left of the unit. You'll need to remove this cap by pushing in the two tabs on the sides of the cap. And then you can install the data logger by pushing in on the tabs slightly into where the tabs insert on the data logger. And then the USB will slide right in to the place where it goes and will lock into place. You can give a slight tug to make sure it is installed securely. The next step in our process is to go ahead and turn our inverter on. So we'll go ahead and allow it to receive grid power. We'll turn our bypass switch over to bypass and we'll begin checking our voltages. As we begin checking the voltages, be aware you are working with live wires. So we will be checking the voltages from line 1 to line 2. We're looking to see that we are getting 240 volts and we're just checking right above these wires here. And we are reading 240 there. Then we'll check from line 2 to neutral. We are reading 120, and then from neutral to line 1, we're also getting 120 there. We'll also check our backup power. Again, we'll check from line 1 to line 2 here. Make sure we're reading 240, which we are. And then from line 1 to neutral, we get 120, and then from line 2 to neutral, we should also be reading 120 there as well. At this point, if you had PV coming in, you could also check your PV voltages coming in. If you were not reading any PV voltage, you would want to make sure that if you had a built-in rapid shutdown button, that is not pushed in. Sometimes your units come with that button already pushed in. To release that, you would untwist that to make sure that button is popped out, then check your voltages again. Now, the next step is to go ahead and turn on your batteries. They each have a breaker inside the batteries, and doesn't matter what order that you flip those on, you will not be able to check the voltages on the batteries until you run through the commissioning process. So we'll go ahead and flip these batteries on. You'll see that our LEDs are showing that they're coming on, and you'll know that they have gone through their startup process when you see the one solid green light come on. It's always best to make sure that your batteries are set up and the firmware is updated to make sure that when you turn on your inverter and begin commissioning, that everything communicates seamlessly. So let's get started setting up our batteries. Now, to find the LG website, what we'll do is search LG ESS battery. And we'll see that it'll be the first one that pops up on our screen, LG ESS battery USA. We'll go ahead and click that. And we'll want to create an account. If you are in the USA, you'll want to select the English website, and you'll want to do partner login. Now, I already have a login here, and I'm going to show you how to create a new account. But before I do that, I want to talk to you about going through the installer training. It's always best to make sure that you go through the installer certification so that if there's any problems, you can make sure that you don't do anything to void your warranty. So let me show you what that process looks like. I've already created my account. We'll go ahead and log in so that I can show you where the installer certification is. Now, it takes me automatically where I can say go to training and go to test. But if I close this out, you could go to where it says YLG Energy Solution or any of these tabs at the top, and scroll down on this second column and it says Certified Installer Test. We can click here, and that's where the pop-up screen comes up, and you can click on Go to Training. And here's the library of videos that you can click on to teach you about the types of batteries that you may be installing. There are different selections here that would take you to the specific LG 16H Prime battery. Not all of them will apply to this battery specifically. Down here is the Resu 10H and how to become an LG certified installer. So there are specific ones that you would want to select for your specific battery. When you are finished watching the videos that you find apply to your battery, you can go back and you can select Take the Test. And when you say Go to Test, it will allow you to enter your information and take the test to get your installer certification, and then you have that information that allows you to say that you are a licensed installer for the LG battery. Now let's show you how to set up your own account so that you can continue with the registration of your batteries. We'll go to a new window, and again we'll type in LG ESS battery. We'll go to the partner login, and we're going to create a new account. So we will say Join Us. And if you wanted to go through the installer training, you would fill out all of this information here. You would select whether you are a home battery reseller installer or home battery distributor, and enter in this information. And that would allow you, once you complete that, to go ahead and take the installer trainer certification test. But in order to actually commission your batteries, we want to create our account on the LG In-Block Manager. So we're going to select this second tab up here at the top. And notice this pop-up window comes up. Now, if you have already been an account user and maybe you've used their old account for the Resu Monitor, which is an old app, you're still going to have to create a new account for the In-Block Manager, and once you do, it will allow you to migrate your information from the Resu Monitor over to the In-Block Manager, and that's what this pop-up window is telling you. So it gives you a manual link for Resu Monitor and new users. Here you can click on that. We'll go ahead and close this window here. and we are going to create a new account. So we're going to sign up. Close this window again. Now it gives you two options. You can log in as a company or you can log in as a DIY do-it-yourself user. Now the difference between these is if you want to log in as a company, that's going to require a lot more information, a tax ID, and a lot of different information. I'm going to suggest select do-it-yourself user, and it's going to require less information. Now that's up to you if you want to select a company and you want to have that kind of registration. So I've entered my personal information and my country. I've selected that I agree and I'm not a robot. I'll click save and confirm. Now it's asking me for a verification code from my email. So I will look up my email and I will enter that. And we will set a password. So we've set our password. Make sure that you do follow the password requirements. Select that you're not a robot and we'll say submit. We get another pop-up menu that says make sure that you look through this because the N-Block Manager is different than the Resu Monitor. And it tells you how to migrate your information from the Resu Monitor if you use that before. If you're a new user, you don't have to worry about this. Now we're going to log in to our N-Block Manager, which we could do here. So we'll go ahead and do that. And there we are signed in. Now we'll use this same login information when we log into the app, which we'll do now to begin setting up our batteries. Okay, so now we're going to go ahead and download the app called N-Block Manager. We can do this from the Apple Store or from the Google Play Store. I have an Apple device, so I'll go to the App Store. And we'll go ahead and search N-Block Manager. And the one that pops up does have a turquoise square and it says N-Block Manager inside of it. I've already downloaded it, so I'm going to click on Open. And you'll just log in here with the same credentials that you logged in with on the computer. And mine went ahead and logged myself in since I've already logged into this before. So once you log in, you'll come to this screen and we'll go ahead and click on Direct Battery Connection and it'll bring you to this screen. We're going to go ahead and commission our batteries. So we will select this top option where it says commissioning. And it does notice that we have already commissioned some batteries and it asks us if we want to do a new installation. You will probably not have this option, so we'll go ahead and click New Installation. Now it opens up your camera and asks you to scan a QR code for the battery serial number. We'll find this QR code underneath our handle on the left-hand side of the battery. So we'll just use our camera to scan this QR code and it will automatically populate for the battery serial number. If for some reason it doesn't, you can find the number here and you can type it in manually. We'll go ahead and say save and proceed to the next step. Now it's going to ask us to type in or to select our inverter brand. So we'll click on that drop down arrow and go down to the list and find the Solis brand that we have our batteries connected to, and we'll select OK. Next, we'll select our model. We have the 11.4 US model, so we'll select that top option and select OK. And once all of that is selected correctly, we'll say save and proceed to the next step. Now it's going to ask us to select the SSID information and connect to the Wi-Fi network of our battery. Now one thing to notice here is we will find the MAC address of our battery on the sticker on our communications board inside of our battery. In order to do this, we'll need to make sure that our battery is on. And the MAC address is the bottom number on this sticker here. Now, one thing to note is it is on there upside down. So one easy way to make sure that you can see it well is to take a picture with your camera and to use your camera options to rotate it and maybe even enlarge it. I like to write mine down so that it's easy to refer to. So when you begin to connect to this, you're looking at this bottom number, which looks like the top number here, but we'll go ahead and say connect. And when you begin to connect to this, the first letters will be Resu underscore, and then it'll be this number that you're looking at. So when we see this populate, it'll say Resu underscore 64, and then these last numbers will be EBA. So we see it populate here. We'll go ahead and select that. And now it's asking for the password. Now your password is going to be this MAC address number, and then you're just going to include the numbers 1, 2, 3, 4 at the end. And for me at this point, if you've written it down, it's easy to look at what you've written down, but it's also easy. I can see my password here at the top, which is my MAC address. It's all the numbers after this resu underscore, and so I'm going to look at it from my phone and begin to enter the password there. So I'm looking at my top of my phone here, 64. And then I'm going to continue to enter those in. And then I'm going to make sure and follow that with the 1, 2, 3, 4 at the end. And we'll go ahead and say join. Once we have entered the password correctly, we'll see a green check mark. And then we can go ahead and go back to our in-block manager. And we can say connect the battery and proceed to the next step. Now here it gives us all of our updates for our firmware. There are 3 updates, our RMD, our BMS, and our DC-DC. It gives us our current version and the latest version on each of these. And you can see all my updates are grayed out, which means that I am updated to all the latest firmware for each of these. If I was not, I could click on the update button and go through each one of these independently one by one. And so we are updated to all the latest firmware, so we'll go ahead and save and proceed to the next step. Now here, this is our last step here. We'll go ahead and connect to our home Wi-Fi. So we'll select the drop-down arrow on this one and select your home Wi-Fi network. Select where you are and select OK, and go ahead and enter in your password there. I'm already connected, so I didn't enter a password. We're going to go ahead and skip that step. At this point, you would enter your password and hit connect if you were not already connected. So make sure and select your time zone, and then whether you are in a single configuration or parallel. We are in parallel, so we'll go ahead and say save and proceed to next step. And then this is our installation summary with our firmware version, our setting info, our inverter information, and our battery status. So we'll select OK, and now it gives us the option if we want to go ahead and commission our second battery since we selected parallel settings. So we'll say OK, and it will allow us to go ahead and commission our second battery. We'll want to make sure our second battery is on as well. And we'll scan the serial number underneath the handle, just as we did the first one. That will populate for us, and we can say save and proceed to the next step. We'll enter our inverter brand, select the drop-down arrow, and under the list, we'll select Solis and the inverter model, 11.4 US, and select OK, save, and proceed to the next step. And once again, this is going to be a different MAC address. We'll find it on the sticker on the communications board. And this is going to, again, say resu underscore, and it's going to end with some different numbers. So we'll select the one that ends in FE this time. And it's going to be a different password, but again, we're going to enter the 1, 2, 3, 4 at the end. And again, I'm using my cheat up at the top for my MAC address as my password. And we'll know we did it correctly when we get a green check mark. And we can go back to our in-block manager and say connect the battery and proceed to the next step. And here, this battery has not been updated for each section to the latest firmware. Our RMD is on the latest version. Our BMS is not on the latest version, so we'll go ahead and click update and allow that to go through its updating process. It says it may take up to 10 minutes. So if you get this pop-up block that says it wants to join Wi-Fi, just click join again and make sure you're still connected to the right network. It looks like we have been updated. We are on the latest version, and all of our RMD, BMS, and DC-DC are all updated. They all say they're on the latest version. And so we'll say save and proceed to the next step. And again, we're on our last screen where we say we are connected to our Wi-Fi. If you were not connected, you would go ahead and set up your local Wi-Fi connection here. Your time zone, you would set that up here. And single or parallel connection here. If it was on single, you would go ahead and select parallel here and say save and proceed to the next step. There you are on your installation summary, where it tells you your current firmware versions, your setting info that you are in a parallel configuration, your inverter information, and the battery status of your second battery or your secondary battery. And you can say OK. At this point, it says the commissioning will end. Would you like to disconnect the battery and register the system? At this point, when you say yes, it says there is no internet connection. After connecting to the internet, please try again. You can try at this point going to your home network. And selecting OK. It's really not going to tell you at this point that you're done, but you are now finished and have successfully commissioned your batteries into a parallel connection. With our inverter on and our batteries on, it's time to go to the Solis Cloud App so that we can finish the commissioning of the system. We'll go to the App Store or the Google Play Store. We'll search for the Solis Cloud App. You can see it's this orange icon with the star and the gears. I already have it downloaded, so I'll click on Open. And I've already created an account. You will have two options. You will have an organization or a homeowner option. Go ahead, if you're an installer, and click the organization account so that you can create an account and have all access. The homeowner account is for the end user account so that they can see what their system is doing. So I've already created an account. I'm going to go ahead and log in. When you're an installer and you've already created systems, as I have, it'll take you to this plant homepage and it'll show you all the systems that you have installed that you see right here. What you need to do at this point is go to Service, and we'll go to this under Common Tools, Local Debugging, and we'll create a Bluetooth connection with this inverter. And you'll see on the top part, you'll see this INV, which is the inverter, and it says nearest connection. This is the one that we want to connect to, INV underscore and this number. We'll click on that. And now we see that this is for an installer. We will need to create a password. Now this is a pro tip. You may not be the only installer that comes to work on the system that you are installing for this homeowner. You're going to create a password for this. Go ahead and write the password on the inside up here so that if anyone comes to work on this inverter, they will be able to log into this system and be able to troubleshoot this for the homeowner. So I'll go ahead and create a password for this inverter right now. If you've not already set up the inverter, it will automatically take you to this quick settings screen, and you will just go through this process. The first screen is your inverter time, and it takes you through the inverter date setting, time setting, phone time. On follow phone time, if that toggle switch is not automatically selected, go ahead and select that so that it will automatically set the time of your inverter to follow the time on your phone. So ours is automatically selected. We'll go to the next step. The next step is to select your battery model. Now we have the LG 16H Prime batteries, so we'll find that on the list and we'll go ahead and select LG 16H and select next step. Now the next one is for our meter setting, and we have the Acryl 1P meter. If you have a different kind of meter, let's say the Chint SP meter, you might want to select that one. So be sure and select the kind of meter that you have. Ours is the Acryl meter and it's already selected, so we will select next step. Then we have the grid code. Our grid code for where we are here in the United States. We will scroll down until we find United States. These are all in alphabetical order, so we'll go to USA. And in the USA, ours is UL 240V18. So we'll select that. Your grid code may be something different. Just make sure that you select the grid code for your specific area. We'll say save. We're good there. So we'll say next step. Our last option is to select our work mode, and the first option on this is self-use mode. Now you would want to select self-use mode to determine what your priority is from your PV. If you want your PV to first go to your loads and then to your batteries, and then once your batteries are fully charged to export back to the grid, that's the one that you would want to choose. The next option that you have is the feed-in priority mode. This would prioritize the power that you're bringing in from PV to feed it first to your loads and then export power back to the grid as your second priority. You would set up the cap that you want to export back, and if there's any excess after that, then you would tell it to charge your batteries. For peak shaving mode, you're limiting the amount of power that you would want to use from the grid. Once that limit has been reached, then you will begin discharging from your batteries. Now the last one, off-grid mode, think cabin in the woods. You have no grid, so you're depending on all of your PV and your batteries to provide power. We have selected self-use mode. We are in these options, so the self-use mode switch is toggled on. So the next option is your time of use switch. This allows you to tell your batteries when to charge and when to discharge so that your batteries aren't discharging all day to cover your loads, maybe when PV is not enough. When PV is not enough and you want the grid to cover the rest of your loads and you want to save your batteries for nighttime use or when PV is not enough. Your next option is allow grid charging. This would just allow the grid to charge your batteries. The battery reserve switch, if you toggle this on, would allow you to set a state of charge percentage at which they would stop discharging as long as they were on grid. So with these settings, we're going to leave time of use switch off. We're going to toggle on battery reserve switch. We're going to leave our reserved SOC at 80% and leave the grid charging power limit at 11,400 watts. At this point, with our self-use mode settings set, we'll click the back button and we can say complete. So we're back to the home page now, and we see a nice graphic, animated graphic here that shows that our inverter is sending power back to the grid and sending power to charge our batteries. The next thing we need to do is limit our export power because we do not want to actually sell power back to the grid. So we will go to settings and we'll tap on this grid feed-in power limit. And the toggle switch at the top that says feed in power limit switch, we will turn that on. And it's already set to 0 feed in power limit value. If that was not set to 0, we could put in a 0 there and we could say save. And all of these other values can stay the same. We'll click the back button. Notice that we set our export power to be 0 export. We don't want to sell back to the grid, but our animated graphic shows that our batteries are charging, but somehow we're sending power back to the grid. This doesn't make sense. There is a troubleshooting process here. This tells me that possibly our CTs have been installed backwards. Now, we did install them according to the manual. In the meter, it says to install them with the arrow pointing towards the grid, which is what we did. However, the manual may have been incorrect. So there is a way that rather than going back to the meter and reversing them there, we can change them electronically. So I'm going to show you how to do that now. We can actually go to settings and we can click on advanced setting. And at the top, we see meter setting. At the bottom here, we see CT direction and it says forward. We can click there and click on reversal and we can say save. And we can click on our back arrow. And when we go back to home and we look at our graphic, now we see something that makes a little more sense. We see that we're pulling power from the grid to charge our batteries. The next setting we want to talk about is the parallel settings. So as we go into parallel settings, you would need to set this up if you have more than one inverter that you have connected in parallel. Notice the parallel mode here, it says single. I only have one inverter, but if you were connecting more than one, you would select this and you would say parallel. So if you selected parallel, at this point you would say save. Now, as we go through here, even though this one is my master, even under at the very bottom where it says parallel sync, I would want to select that on all of my inverters even on the master, to make sure that all of the settings that I have set on my master and my batteries would be saved throughout all of my inverters. So once that's set on my master, I would connect to each of my inverters and I would go through and I would select that each of them are in parallel mode. I would change the physical address for my second inverter to say 2, or for my third inverter to say 3, or on down the line. We would save each one of those. If it's not my master, I would set each of those to be slave instead of master, because I'm only going to have one master, and that is my number 1 inverter, and we would save that setting for each of those. All of those would be single phase, and we would also say the total number of hybrid inverters connected. However many we connected, we would set that number here and say save. And then your parallel settings would be set. So the total number would only apply if my parallel mode was set to parallel, but since it's set to single, this total number doesn't matter. We'll go ahead and click back. And the last thing we need to talk about is device upgrade. Now, the bottom one, hub, will not be important to us, but HMI and DSP, we want to go ahead and check to see if there is a firmware update for our devices. So we'll go ahead and click check the update. And it does say new firmware version found, so we'll go ahead and say download and upgrade. Tells us to start upgrading. We'll go ahead and select start upgrading. We'll go to DSP, we'll check the update. The current version is already up to date, so we are good on the DSP. Got it. Now we're going to talk about your data logger. Your data logger is for remote monitoring. It has 3 lights to indicate you are connected in certain ways. Your first light might be blue or it might be green. If your light is blue, you have a cellular connection. If it's green, you're talking about a Wi-Fi connection. Solid means that you are connected. If it's blinking, it's trying to connect. Your next light will either be solid or it might be blinking every 5 minutes, meaning it is transmitting data. And this second light is yellow, meaning it is communicating with your inverter. And your last light should be red, meaning it has power. Then you have a reset button. If you should, for any reason, need to move this data logger to another inverter, or your password on your Wi-Fi changes, you may need to hold that reset button down for 10 seconds and go through the commissioning process again. To set up the data logger, we'll need to go back into our app. And so I'm back on our home screen. I'll go into the orange Solis Cloud icon. We will click on the service tab on the bottom, and we will click on Wi-Fi configuration this time. We have a box that says please enter the configured data logger, and we can select this box on the right, which will open up our camera and allow us to scan the QR code sticker on the front of the data logger. So we'll use our camera to scan the QR code there. And it will automatically populate. If for some reason this number does not automatically populate, you can manually type it in as well. So we'll click next, and we'll select configuration by Bluetooth on this pop-up window. And we get a list of different devices. We will want to select the one that starts with a D at the top, D underscore, and the same number that is on the sticker on your device. So we'll select the top one for us. And now it asks for our Wi-Fi name and our Wi-Fi password, and we will see our serial number at the top, which once again is the same number that you see on your sticker on your data logger. So we can say select Wi-Fi, but before you do this, you need to be aware that this will only accept a 2.4 gigahertz frequency Wi-Fi band connection. It will not accept a 5 gigahertz, so make sure that you do have capabilities for a 2.4 gigahertz frequency. We'll go to select Wi-Fi, select my Wi-Fi. It gave me an option of Wi-Fi, and I will select my 2.4 gigahertz option. And go back to the Solis Cloud app, and I will put in my password. And click Start Configuration. It gives me a pop-up window. The data logger is currently online. Continuing the configuration may change the network configuration. Are we okay with that? Yes, we'll click resume and start configuration. And now I clicked it again, and now it is searching for the distribution network, and we got success. We'll say complete. So since I got the success check mark, I can just back out of this. So the next thing we want to do is to create a plant. So we'll go to the bottom left to create a plant, and at the top right, we see a plus sign. We're going to add a plant. So we'll click the top option, add plant, and we're going to enter all the details of this system that we just set up. So we'll enter our plant name, our plant type. This is residential. Capacity. All of these items do have an asterisk beside them, so they do have to be filled in. Your organization code will be automatically populated. So if you're commissioning this system for someone else, you would put in their organization code. So your feed-in tariff is going to be the rate at which the utility company charges you for power. You have some options here. You can do a fixed tariff or a peak valley tariff. We're going to select fixed tariff, and the tariff is how much you get charged per kilowatt hour. So we're going to say 11 cents per kilowatt hour for us. We'll select next. The link account will allow the installer here to set owner, which will be the homeowner, so that they can view their account, and it will send an email to the homeowner to allow them to create an account so that they can see what their energy management is doing. They can also, you can add as many guests as you want, and they can send emails here. Then you can click on more info, or we'll click next, and you can input your email and your phone number and the times that you set this up. And we can say create plant. You can take a picture of the plant setup and have all of that recorded right here. So once you click next, it asks you to add your data logger, and once you add your data logger, this will add your inverter as well. Now be sure that you are adding the QR code or the serial number of your data logger, and we will scan it once again. And everything has successfully been added to your plant. So let's get everything closed up and prepare for our load test. So we're all set up for our load test. We do have grid power coming into our inverter. There's just a couple of things that we need to do. Our bypass switch has two settings. In the event that we want to operate as backup power, we need to make sure that our switch is set to inverter. If in the event that we're having problems with our equipment, we need to switch it to bypass. Since we are operating in backup power, we need to switch ours to inverter, so we'll go ahead and do that now. Then we need to turn our inverter on, and we'll do that by turning on the PV disconnect switch to the on position. This is like your on button for your inverter, whether you have PV or battery connected or not. So we'll go ahead and turn that on now. So it'll take about 5 minutes for this to turn on. You'll know it's turning on when you hear a series of clicks. If you don't hear a series of clicks and it doesn't turn on, be sure and go to the Solis Cloud app and check the alarm page in the app, which we'll look at here shortly, to determine if there is a problem with your inverter and what the alarm is, or reasons why it may not be coming all the way on. With our inverter on, we can look at some of the LED indicators. We can put our finger on this inverter operation light. It is a solid blue, this circle. It tells us that everything in operation for our inverter is good. If this circle was an orange or a red, it would tell us that we have a fault and there is a problem with our inverter. Right now, we are good to go. Right above this circle, we have a battery LED indicator. This tells us the state of charge of our batteries and that we have good communication. Right now, it tells us that we have a little more than 25% charge on our batteries. Looking down below, we see a Bluetooth icon. This tells us that we are connected with Bluetooth via our app. We're ready to begin with our turning on our loads and begin looking at some of the things that we have access to in our app. Right now on the app, you can see that I'm pulling a little more than 2,000 watts from the grid to charge my batteries. If you could see the batteries, you would see that each of them have an additional green light on the batteries saying that they are charging. Right now, I'm going to turn on each of these loads. I have an air fryer here that we will begin to operate. We'll turn on our heat gun. And a heater. And in the app, you can see that we are sending some power to our loads. Now, each of these icons in the app, this would tell us our PV power on the top left. It shows our battery on the bottom left. On the top, it shows us our grid. In the middle, this would be our main power panel. And on the back, this would be how much power that we're drawing if we are on grid. And on the bottom right would be our backup loads. Now, we're seeing most of our power going to our backup loads because that is where all of our backup loads are connected. We see that we are pulling right now a little over 5,000 watts from the grid. We're sending just over 2,800 watts to our loads and still sending just under 2,000 watts to our batteries. If you click on the info tab here at the bottom, you have access to some other information. On this first tab for your inverter, you can see PV voltage and current, and you can also see firmware version of your inverter. You can click on your battery tab at the top, and here you have battery information. You can see for each battery that you have in parallel. You can also see battery voltage and current as well as battery firmware version here. You can click on grid. Here under grid data, you can see your meter data for line 1 and line 2 and the current information. And underneath here, you also see something called revenue grade meter data. Now, this is an optional purchase if you have a power purchase agreement or a lease option and you need higher accuracy, precision in your meter. You may need to purchase one of these and you have that option, and that reading will be recorded here. You can go over to your load data and you can see all of your voltage and current readings here as well. Now, the next tab that you have at the bottom right is your alarm data, your current alarms, which we don't have any currently, and any historical alarms that you've had. You can look through your historical alarms if you need to access any of that. Now, for the fun part, we get to use our lamp to see our transfer time when the grid shuts down and watch our battery backup take over. So let's go ahead and shut off our grid power. Barely saw the light blink. Heater, heat gun, and air fryer are still working. We can see the white light now on our batteries, which means they are discharging in the backup mode, which is now providing power to our loads. You can see in the app, we are no longer getting any power from our grid. All of our power to our loads is now coming from our batteries, and the system will continue to run like this until your batteries reach their over discharge limit. Thanks for watching the full installation and commissioning of the Solis 11.4 kilowatt high voltage inverter paired with the LG 16H Prime battery. You can find this bundle and more at signaturesolar.com, along with expert support to help you get started. I'm Kelly with Signature Solar, empowering you to own your own power.